Okay, Math 2 3.3 factored form notes. So let's read the directions here. Identify the vertex, the axis of symmetry, the min or the max value, the y-intercept, and the x-intercept of each. So that's a new thing, the x-intercept. So for starters, let's talk about what is an x-intercept. An x-intercept is where it crosses the x-axis, right? So normally y-intercept has something that looks a whole lot like 0 and then your y value, where your x is always 0. Your x-intercept, you're going to have x and a 0, where your y is always 0, right? So for these problems, what we're actually going to start off doing is we're going to find those x-intercepts first. Because of the way that parabolas work, we should kind of see that there would either be no x-intercepts, that would be, this is not correct, but I'm just going to sketch it here. If it was like this, it would not have an x-intercept. If it happened to be like the parent function and it touched right there, it would have one intercept, or a lot of these problems are going to have two intercepts, one here, one there. Okay, so to start off finding x-intercepts, we're going to use that idea that I talked about right up at the top, where your y value is 0. We're going to take this equation in number 1, and we're going to set it equal to 0. So we're going to say, well, 0 equals x minus 3, x minus 1. Okay? You've probably solved equations like this before. You should really quickly see that, well, either 0 equals x minus 3 or 0 equals x minus 1, which means that x equals 3 or x equals 1. I guess it can be an and/or, but I'm just going to leave it as that. So our x-intercepts are 3 and 1. Okay? Let's graph that on our graph. So I've got a point at 3 and I've got a point at 1. Okay. Next up, let's talk about our vertex a little bit. Vertex. Our vertex is going to be a point, just like normal, but there isn't an easy way to grab it from our equation. But what we can do is we can kind of think about what do our x-intercepts mean whenever we have a parabola. Now, if we look at this, we would have to have a parabola, and this isn't necessarily correct, I'm just kind of sketching it. We'd have to have a parabola that does something like this, or a parabola that does something like this, right? That's really bad, but oh well. Okay. It could be really stretched out where it goes really high up, right? But we know that parabolas are symmetric, right? That means there's the axis of symmetry. So we know that the middle of this parabola is going to have to happen right between these two intercepts. In this graph, it's really easy to see that the axis of symmetry is going to be right here. Okay. That would mean that our vertex would happen on the x value of 2, right? And we could also put our axis is x equals 2. Now, I know we kind of were able to just look at that on the graph, but I want to show you how you could do this by hand in case the numbers were kind of wonky. You take your x-intercepts, your 3 and your 1, and you find the average of them, right? So I'm going to say 3 plus 1 divided by 2. That's 4 divided by 2, which is 2. Okay, so I get this 2. That's the same as that 2. It's the same as that 2. Okay, now we're only halfway done with the vertex. We have to find that other part. To find the other part, we're going to have to plug into the equation. So I'm going to say, well, y equals 2 minus 3, 2 minus 1. Okay, this is the same thing as negative 1, negative 1, 1. Negative 1 times 1 is 1. Okay, so our vertex has a 1 in it. That 1 and that 1 came from each other. All right, what else do I have to find? We found the vertex, we found the symmetry, we found the min-max value. Do we think this guy's going to have a min or a max? Well, our vertex is at 2, 1. Wait, hold on. Oop, I messed up. I'm so sorry. If we go back over here, we have -1 times 1, which gives me a -1. Okay. That also means that in our vertex, we have a -1. Let me put that in orange so that you guys all look at it. All right, I screwed up right there, which changes the way that our vertex was going to get graphed. It would go over 2 and down 1. There we are. Okay. Now we have 3 points. We can kind of sketch what it would look like. It's going to be something along the lines of that. So we're going to have a min at y equals -1, right? Because it has a bottom, and that -1 comes from the vertex. Now, last up, we have to have a y-intercept. The y-intercept happens whenever we plug in 0 for x. So we have to do another step. These kind of get long. I'm going to say, well, I'm going to plug it in like this. F of 0 equals 0 minus 3, 0 minus 1. So I've got -3, -1. -3 times -1 gives me a +3. See, I can do that math there. So this 3 tells me that my y-intercept is 3. All right, let's go on to number 2. Number 2, we're going to start off by plugging in a 0 for y. So 0 equals -x minus 7, x minus 4. This means that this negative out front, it's not going to matter a whole lot. So we're going to say, well, 0 equals x minus 7, 0 equals x minus 4, x equals 7, x equals 4. So this tells us that our X-intercepts are 7 and 4. So I'm going to put a dot on 7 and I'm going to put a dot on 4. Our vertex and our axis of symmetry are the next things to do. We're going to need to average the X-intercepts. So I'm going to take these two right here and I'm going to average them. I'm going to say 7 plus 4 over 2, 7, 8, 9, 10, 11, 11 over 2, which is 5.5. Or in this case, I'm just going to put 5.5. So our vertex starts off with 5.5, and our axis of symmetry is 5.5. Let me write this just a little bit better. All right. To find the other half of our vertex, I'm going to have to plug into that equation. So we've got y equals negative parenthesis 5.5 minus 7, 5.5 minus 4. All right, I'm going to see if I can just type this whole thing in my calculator. I've got negative parenthesis 5.5 minus 7, 5.5, is it minus 4? There we are. All right, and I got 2.25. Okay, thank you, Desmos. All right, there we are. There's our vertex. Okay, Now, I know that we don't have hash marks on the grid to show us what 0.25 and where 0.5 are, but we're just going to have to guess. So we're going to have 5.5 and up 2.25 will put me somewhere like that. Something along the lines of that. All right, what's the is how much more do I have to get? We have a max value here at y equals 4. Right? I grabbed that 4. Oh, not 4, excuse me. 2.25. The 2.25 came from the 2.25 in our vertex. And then last up, I got to get my Y-intercept. My Y-intercept, well, that happens whenever x is 0, right? So I'm going to have to say, well, y equals negative 0 minus 7, 0 minus 4. So to solve this, I have y equals negative 7, negative 4. Okay, here I'm going to count my negatives. I've got 1, 2, 3 negatives. I'm going to be left over with 1 negative at the end. So I've got a negative. 7 times 4 is 28. So my y-intercept is negative 28. All right, there we are. That's number 2. On to number 3. We're going to start off by setting it equal to 0. So we're going to say, well, 0 equals 1/4 x minus 7, x plus 2. Okay. And when we solve this 1/4 doesn't matter a whole lot. It's just going to get absorbed in that 2, in that 0. So that 0 equals x minus 7, 0 equals x plus 2. This is x equals 7, and this is x equals negative 2. So our X-intercepts are negative 2 and 7. And we can graph that on our graph. Our vertex and our axis of symmetry are the next things to find. We're going to average our x-intercepts. We're going to say, well, negative 2 plus 7 over 2. That's 7/6 5/2, which is 2.5. So in my vertex, my x value of my vertex is 2.5, and my axis of symmetry is at 2.5. To find the other half of my vertex, I've got to plug into my equation. So I've got, this would be like plugging in f of 2.5. I've got 1/4, 2.5 minus 7, 2.5 plus 2. All right, and just like last time, I'm just going to see if I can type this into the calculator. I've got 1/4, 2.5 minus 7, 2.5 minus, plus 2. And I'm just going to say 5.06, well, I'll say the whole thing. 5.0625. I think that's an eighth. All right, there's the other half of my vertex. So I can go over to 2.5 and up about 5, a little over 5. There we are. My parabola is going to open up and be pretty wide. There we are. We have a max here. Our max is at y equals 5.0. Hold on. Oh, I did it again. This is a negative. There was a negative in front of my 5. Let me write that in orange so that we catch it. Negative, negative. And we're going to have to erase our parabola. I'm sorry, guys. Alrighty, I think I fixed it. Alrighty. I have a min, not a max anymore. I have a min at 5.0625. Alright, now for my Y-intercept, I'm going to have to plug in 0 into my equation. So I'm going to have y equals 1/4 0 minus 7, 0 plus 2. Y equals 1/4 negative 7 times 2, which that's the same thing as negative 7 divided by 2, right? What I did here was I combined the 2 and the 1/4. And negative 7 divided by 2 is negative 3.5. So my y-intercept happens at negative 3.5. Okay, number 4. You know what? I'm going to skip number 4. You guys can do number 4 on your own. Number 5. My x-intercept is what I start off with. I'm going to say, well, 0 equals negative x plus 5, x plus 1. This means that 0 is x plus 5, or 0 is x plus 1. So x is negative 5, or x is negative 1. So my x-intercepts are negative 5, negative 1. If I average those, well, let's go ahead and graph it first. Negative 5, negative 1. If I average those, negative 5 plus negative 1 over 2, that gives me negative 3. So my axis of symmetry is at x equals negative 3. My vertex starts off at negative 3. To find the rest of my vertex, I'm going to plug into the equation. So I've got y equals negative parenthesis, negative 3 plus 5, negative 3 plus 1. This gives me negative 2, then another negative 2, which gives me, is that a positive? Yes, positive 4. So my vertex has a negative 3, 4. And I can put that on here, negative 3, 4 is all the way up there. There we are. We have a max here, a max at y equals 4. And to find our y-intercept, I'm going to plug in zeros for my x's. So I'm going to have y equals negative parenthesis 0 plus 5, 0 plus 1. And if I multiply that out, I get negative 5. So my y-intercept is at negative 5. All right, there we are.